Hi, welcome to Block 5, Addition and Subtraction of Fractions, Lesson 12. I'll share my screen. So, in your previous lesson, you learned how to use equivalence to answer what would seem to be some really difficult maths questions. But once you know equivalence, they become really easy. Now, in today's lesson, you're going to learn how to add and subtract simple algebraic fractions. It is your last lesson of Block 5, so really well done for taking your learning seriously and for sticking around. Remember to like the video, to subscribe to the channel, share the video with those you think can benefit, and click on the notification bell so that when new videos are released, you will be notified. Before we start, I would like you to pause the video and answer these retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. For this one, you were simply asked to simplify the expression by collecting like terms. So 3x add x plus 2x will be 4. 3x add x will be 4x, add 2x will be 6x. 6x minus 4x will be 2x. Here you were asked to explain why the calculation is incorrect. The calculation is incorrect. You can do this in two ways. So you can do this by doing the calculation and to actually prove that it is not equal to 4/8, or you can do this by reasoning that 4/8 is actually half, okay? And 2/3 is already greater than half. So you cannot be having a result that is less than half when you add in something that is greater than half to 2/5, okay? So that's one way of reasoning. And then next you were asked, write down the mathematical symbol. This is a greater than symbol. Let's do some new learning for this lesson. If you're asked to work out this calculation, what would you do? Well, remember the very fact we have learned when we worked in adding fractions. When the denominators are equivalent, we can simply add or subtract the numerators. So our answer will simply be 2/5. So I'm going to show bar models that represent the calculations, but I really want you to understand this the abstract way, because you already have been working in an abstract way. You know how to work with fractions that have the same denominator. So we'll stick to that. That is 2/5. What about this one? We have the denominators to be g. So we simply just replace the numbers with letters. Remember, in maths, we use letters to represent what we don't know. So G could be number of parts that we don't know. Okay, but it doesn't change anything. We stick to the principle that when we have equivalent denominators, we can simply just add the numerators. And that's it. Your answer is 2/g. Here is this one. If you're asked to work out this calculation, you can see that the denominators are equivalent. So we can simply just add the numerators. So I'll just use the bar to represent, but I wouldn't really pay much attention to that. The bar is there for you to visualize what is going on. So that is 6/7, 6/7. What do you think we will do here? Well, it's not very much different. By now, you know your principles of algebra, and you add to that knowledge the principle that if you have the same numbers in the denominators, you simply just add the numerators. So x plus x is 2x, okay? 2x/7, all right? So we know we'll have 7 parts, but x means we don't know the number of parts we'll shade. It doesn't make any difference. We just stick to the principle that we know that x add x is equal to 2x, and we add to that knowledge the fact that when we have equivalent denominators, we can simply just add the numerators. Interesting, isn't it? Okay, What about this one? When we do subtraction, you would say, I know, it's 2/5. We simply just subtract 1 from 3 because the denominators are equivalent. But what about this one? You think, okay, this is interesting, isn't it? But it really is not difficult. We simply just have the same denominator. We just happen to have a variable in the denominator, this time not a number. So we will maintain the same principle. The principle is we're going to have something over x because the denominators are the same, so we can keep it that way. So we'll simply have 3 minus 1, which is 2 over x. Okay, the bar model simply shows you we don't know the number of parts that we're working with, but we simply know that we subtract 1 from the other one. Okay, what about when we have different denominators? What did we do? Well, we simply made the denominators the same, right? If they shared a common multiple, we simply made one equivalent to the other. In this case, which one would we use? Of course, it's the 1/5. So we're going to have to multiply. Okay, remember when we did the bar model, it's a bit like splitting the other bar model to have equal number of parts so that we can then add them. And that is equivalent to finding an equivalent fraction that has a denominator of 10, equivalent fraction to 1/5 that has a denominator of 10. So in this case, we simply multiply by 2. And of course, remember, whatever you do to the denominator, you have to do it to the numerator. So in this case, 1/5 will be you multiply the denominator by 2 and you multiply the numerator by 2. So you simply have 3/10 as your answer. What do we do here? Have a think. Well, do you think we must make the denominators equivalent? What's your answer? Yes. But how? 2p, what do you think 2p is? 2p is 2 times p, right? So how do we make the other p become 2p? It's by multiplying it by 2. You see how easy it is? So if we multiply p by 2, we have to multiply 1 by 2 because we have to do whatever we do to the denominator, we have to do the same to the numerator. You see how easy it is? So, of course, ignore the bar model for now. It's just to show you, I've used the bar model to, represent, to show you how things actually work. So it's simply just multiply by 2. So we multiply the denominator by 2 and the numerator by 2. Because whatever you do to the denominator, you have to do it to the numerator. And it simply just becomes 3 over 2p. It's that simple. Okay, I want you to have a think at how you would do these other ones now that I have shown you how to make the denominators equivalent when we have variables in the denominators. Okay, assuming you've paused the video and you've really had a good go, you've tried, here are the answers. So here, we simply multiply by 3. Why? 3p means 3 times p. So by now, you understand these algebraic terms, what they mean. So if you haven't, please go and watch our videos from term 1 where we have really built our foundation in understanding basic algebra. So it means we're going to have to multiply this by 3, okay? Now, whatever you do to the denominator, you have to do it to the numerator. That's why we have this, which is an equivalent, okay, an equivalent fraction of this one. All right, so 3 over 3p plus 1 over 3p, that will be 4 over 3p. What about this one? I think you spotted the pattern. We simply multiply by 4. So you multiply this by 4. You have to multiply that by 4 as well. We have 4 over 4p plus 1 over 4p. Of course, the denominators are equivalent, so you simply just add or subtract the numerators depending on what you're given to work with. It's now time for you to practice what you've learned, right? It's easy, isn't it? So pause the video and answer question 1 in 2 minutes. Assuming you've answered question 1, here are the answers. Let's discuss them. So here, we'll simply just add the numerators. Why? The denominators are equivalent. We just add the numerators. All right? And then you're asked to double a fraction, you just double the numerator. Okay? Of course, yes. Yes. So she's right. Pause the video and answer question 2 in 3 minutes. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. So here, you're simply asked to work out the calculation. You can see the denominator is equivalent, so you simply just add the numerators. Okay, here, you see? Here, that's all we do. Here, we have to make this equivalent to 4, right? So just a minute, let's go back. Okay, so this has to be multiplied by 2. So you multiply this by 2, and you multiply that by 2. Okay, so this becomes 2 over 4 plus 1 over 4, which is 3 over 4. Here you multiply this by 2. Why? You make the denominators equivalent, because if you do that, you just have to deal with the numerators. Things become really super easy. So that becomes 2 over 10, add 1 over 10, which is 3 over 10. Here, you have to make this equivalent. So you multiply that by 2. That will make it 58. So that will now be 2 over 58 plus 1 over 58. So that will be 3 over 58. And then here, we simply multiply by 2. That makes it 2x. So this becomes 2 over 2x, add 1 over 2x. Of course, the denominators are equivalent, so we can simply just add the numerators. So that's 3 over 2x. Pause the video and answer question 3 in 3 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. So here, you're asked, Annie is calculating with algebraic fractions. She says, I can work out 1 over k plus 1 over k because the denominator is the same. Of course, she's right. So she says 1 over k plus 1 over k will be 1 plus 1 over k. Next, you're asked, use Annie's method to complete these calculations. Of course, you can see the answers, right? So the denominators are equivalent, are the same, so you simply just add or subtract the numerators, okay? So this will be 3 add 4, this will be 12 subtract 5, which is 7 over n, okay? 1 minus 4 is negative 3, so it doesn't change anything. You maintain the same principles you know in maths, provided you know you're doing the right thing, okay? So your answer will be negative 3 over p. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. So for question 4, you were asked to, here is an algebraic expression, okay? You were asked, write the expression as a single fraction, okay? You just write that, okay? So you just add the numerator, that's 6 over r. Evaluate the expression when r is 2. Remember, to evaluate means you need to substitute what you've been asked to use, and you'll come out with a single answer, okay, a number. So here, 6 over r, if r is 2, using this one means 6 divided by 2, which is 3. Here you ask, for what value of r is this greater than 1? So you then need to start testing some numbers. Okay, you can try. You already know how to evaluate the expression, so you need to start testing some numbers. So you have, you test 4, you test 3, but the value is, okay, of course, 4. Okay. Now, pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. Here, to do this, you have to make the denominators equivalent. How? You multiply this by 3. Okay, that makes it 3x, and you have to do it to that side as well. So this becomes 3 over 3x plus 1 over 3x. The denominators are equivalent, so you simply add the numerators. 3 plus 1 is 4 over 3x. This one, we want the denominators to be equivalent, so we multiply that by 5, and we do the same to the numerator, because in a fraction, whatever you do to the denominator, you have to do it to the numerator. So you now have 10 over 5x minus 3 over 5x. The denominator is the same. It's just like we did fractions when we were working with numbers, just numbers. It's just 10 minus 3, which is 7 over 5x. Okay, so that's straightforward. Okay, I just want to check something, and then we will carry on with the lesson. Just a minute. Okay, so thank you for your patience. All right, let's share my screen again. Okay, so sometimes we may have problems that may seem quite challenging. So here, the number line shows 0 and y. Okay, now you are asked to position the expressions on the number line. Okay, so we want to position 2y minus y over 2, right? Now, I want you to know that 2y minus y over 2, I want you to know that we can rewrite this as 2y minus half y, right? If I ask you what is 2 minus half, you will tell me it's 1.5, right? We just have y in front. It's not much different. So this is 1.5 y. Yeah. So what they're actually asking us is to position one and show where 1.5 y would be. But think about it. We have 1, 2, 3, 4. So we have 4 intervals making 1y. So it means the next 4 interval will be 2y. Now, if 4 interval is equal to 1y, it means it's a bit like saying 0 to 1 is 4 interval. So if you were to divide 1 by the 4 intervals, it means each of these interval is a quarter. So this is a quarter y, a quarter y, sorry, a quarter y plus another quarter y, half y, 3/4 y, and then 1 y. So it means each of these is actually a quarter y. So to take half, we have to be here. So that has to be 1.5. It should be there. Interesting, isn't it? It may look like a difficult problem, but it really isn't. Okay, here is another one. If we want to position this one, what does it really mean? 3/4 y plus y, remember y simply means 1y, is 1 3/4. We already know that each of these, okay, is a quarter. So they're asking us where 1 3/4 will be. So this is 1, this is a quarter, a half, okay? That has to be 3/4, doesn't it? Yeah? Interesting, isn't it? Okay? So your calculation is made really easy by really thinking about, in simple ways, the basic principles that you understand about fractions, about algebra, right? About number lines, how to find intervals. Okay, so if you haven't learned about how we work with intervals, how we figure out what each interval is worth, please go and watch our lessons that we have done this about. Now, here is this problem. If we have different denominators, what did we do? Of course, we made them equivalent fractions. We looked for the lowest common multiple and we made them equivalent fractions and we simply added or subtracted the numerators. It's exactly the same thing we'll do here. Okay? So we know that the lowest common multiple of 3 and 5 is 15. Now, how did we make 3 become 15? We multiply by 5. Remember, whatever you do to the denominator, you have to do it to the numerator. So it means we have to multiply the a above the 3, the a in the numerator of 3, by 5. And we have to multiply 5 by 3 to make it 15. Okay? And we have to do the same to the numerator. So what seemed to be difficult now becomes really easy. Now, imagine that there were no letters there. Imagine that it was just 1. You would do exactly the same thing that we've done here, but we simply just have letters there. So your answer becomes 8a over 15. If there was no letter, you would do the same thing. You would have 8 over 15 as your fraction. Okay, what about this one? What is the common multiple of 2 and 7? If I asked you, you would say, it's 14. So how do we make this 14? We have to multiply that by 7. We have to do the same to the numerator, and we have to multiply the 7 by 2. We have to do the same to the numerator. So your fraction actually becomes this. And remember, if you have equivalent denominators, you can simply just add the numerators. So your answer becomes 32 over 14h. Of course, you can simplify it because you can see that 2 is a common number we can use to divide it. So your answer can be simplified to be 16 over 7h. Okay, here is one that could look a bit challenging, but it really isn't. We're going to do the same thing. So we have to solve the left-hand side. So solving means we need to find the value of z. So I'll show you two ways of thinking about this. So first, we know we have to have both of them being 15z. If it was just a number, you would do the same thing. We just have a letter z. Now, we have to multiply only the left-hand side because the other one is already 15z. So we'll multiply by 3 to make it 15, and we have to do the same to the numerator. So we now have 12 over 15z minus 2 over 15z. This is now 10 over 15z. Now, this is one way of doing it. Remember, we are dividing by z, but we actually want z to be on its own. Z is at the denominator at the moment. So we want to make sure z is not doing that. Z should be on its own, not dividing in the denominator. So we can do that by multiplying by z. And that gives us 10 over 15. So if we multiply both sides by z, it gets rid of z from here because multiplying by z on the left-hand side eliminates z, which is dividing here, and we have z on this side. And that gives us our answer. Another way of thinking about this is by saying, well, we want z to be on its own. Z should not be dividing. It should be standing on its own, either multiplying something so that we can divide by what the coefficient. Coefficient means the number next to the z. So we can say, well, if we have 10 over 15z, so this is another way of thinking about it, equal to 1. And this works even if you have a number here or something else. So we need to multiply both sides by 15z. That is one way of doing it. This is now gone from this side. We now have 10 is equal to 15z. Now remember, we want z to be on its own. So something has to go, and which is the 15. The 15 is multiplying the z. I write z like this so that it doesn't look like 2, right? So to do that, we have to do the inverse of multiplying by 15, which is what the 15 is doing to the z. And you see, we get the same result. So you choose the method you like to use, but we'll get the same result. Okay? I particularly like the one on the right side, the one I'm showing you, because it's a systematic way of doing what we already know how to do, but step by step by step by step to get to the answer. And of course, we can simplify this to be 2/3 because we can divide 10 by 5 and we can also divide 15 by 5. It's now time for you to pause the video and practice what you've learned. So pause the video and answer questions 6 and 7 in 4 minutes. Assuming you've paused the video and you've answered questions 6 and 7, here are the answers, okay? So I'm not going to go into detail with this. You can, refer to what we've looked at, but by now you know how we put this information on the number line. So you were simply asked, position the expressions on the number line, write a simplified fraction where required. So you have 0 to 1 to x. Remember, x can be 1x. Yeah. So you have 1, 2, 3, 4. So it means each of these is a quarter. Okay. And you can begin to position these. So it means the next lots of 4 will be 2x. All right. Each time you're adding a quarter. So remember, if it's a quarter, this should be 4 over 4, which is 1, 5 over 4, 6 over 4, which you can simplify to be, 3 over 2x, and then so on and so forth. Here you were asked, a sequence starts at 0 and goes up by a over 5. So you're adding 1/5 every time, yeah? Write the first 5 terms. So if you start at 0, you'll have a over 5. The next one, if you add 1/5 to another 1/5, you'll have 2/5. But you just simply have a in front of it. Okay, it's that straightforward. Next, another sequence starts at 0 and goes up by 2/5 a each term, right? So write the next 5 terms of the sequence. So every time you're adding 2/5. So you just simply have a letter in front. So 2/5, 4/5, 6/5, so on and so forth. All right, pause the video and answer question 8, 9, and 10 in 6 minutes. Assuming you've paused the video and you've answered questions 8, 9, and 10, here are the answers. So here are the answers for question 8 and 9. For question 8, you were simply asked to simplify the expressions using equivalent fractions. Equivalent fractions mean make the denominators equivalent. So here we'll multiply this by 3 because we know the lowest common multiple of 2 and 3 is 6. And we'll multiply this by 3. We'll multiply this by 2. And we'll multiply this by 2. Okay, so now this becomes 3x over 6 plus 2x over 6. And you can see y is 5x over 6. Okay, 3x plus 2x is 5x. Here, we multiply this by 2 to make it 6, and we'll multiply this by 2 as well. We'll multiply this by 3 to make it 6. We'll multiply this by 3 as well. So now we have 4x over 6 minus 3x over 6. Okay, the denominators are equivalent, so we simply just subtract the numerators. So 4x minus 3x will be x over 6, right? Next, we're asked to solve these, right? You can see the denominators are equivalent. We simply just add the numerators. So this will be 4 over x equal to 1, all right? Remember what we did? I'll use the first method we used for the other one. We're simply dividing by x, so we can just multiply by x, which gets rid of x on this side, and this will be x equal to 4, right? Here we do the same. We simply add the numerators, okay? So this will be 8 over y equal to 1. Okay, we want the y to be on its own, so we need to get rid of it here. It shouldn't be dividing. So we'll multiply by y, and we'll multiply by y. It gets rid of y on this side. Y is 8. Here, we have to make the denominators equivalent, right? So we need to multiply that by 2 and that one by 2. So now this becomes 22 over 2z minus 9 over 2z, right? 9 over 2z. Now the denominators are equivalent. So this becomes, when we rewrite this, this becomes 11, because 22 minus 9 is 11. 11 over 2z is equal to 1, right? We can multiply both sides by 2z. We don't want the z to be dividing, so we can multiply both sides by 2z. That's now gone, okay? So we now have 11 is equal to 2z. And you remember, when you are, what is preventing the z from standing on its own is the 2 which is multiplying the z. So let me put a cross there so it doesn't look like 2. Which means we have to divide both sides by 2. Remember how we solved equations? Okay, you see how everything is connected in maths. Really interesting, isn't it? And your answer will be, just a minute. Yes, we're right. So we have, our answer will be 5.5. Okay. All right. Okay, so here is question 10. So you were asked, how would you simplify this expression? So we'll just discuss it really quickly. To simplify these expressions, you multiply this by 3, okay, to make it 6x. We need the common multiple. You multiply this by 2. You have to do the same to the numerator. Here, you would make all of them 6 as well. So you multiply this by 6. You multiply this by 3. You multiply this by 2. And that brings us to the end of our lesson. Well done for sticking around. So being able to add and subtract algebraic fractions is not as difficult as we think. If we apply our knowledge of knowing how to work with equivalent fractions, things become really easy and accessible. Well done for sticking around and for taking your learning seriously. Until next time, take care of yourself, your friends and family, and bye-bye.